Okay, this is lesson 7.4. We're going to be talking about special parallelograms, which are rectangles, rhombuses, and squares. These are the three special parallelograms that we talk about. We want to start with their definitions. The definition of a rectangle is a parallelogram with four right angles. A rhombus is a parallelogram with four congruent sides. And a square is a parallelogram with four right angles and four congruent sides, meaning a square is basically a rectangle and a rhombus put together. These are the basic definitions of these shapes. They have lots of special characteristics, but these are their definitions to begin with. Okay, so then let's go on to talk about what makes a rhombus, what's special about a rhombus. Well, there's two things that I want you to know about a rhombus. The first is that the diagonals of a rhombus are perpendicular. So if I draw one diagonal from this corner to this corner, and I draw a diagonal from this corner to this corner, oops, I didn't draw a diagonal. There we go. Those two diagonals are always going to meet at a right angle. They're always going to be perpendicular. The other thing is the diagonals of a rhombus bisect its angles. Now, we already knew that the diagonals of a rhombus bisect each other because it's a parallelogram. So we know that this is congruent to this, and we know that this piece is congruent to this piece. But this here is talking about the angles themselves. So the diagonal that we drew first, it bisects this angle right here. So this angle is congruent to this angle. And this little angle is congruent to this little angle. And then we also know that this angle is congruent to this one. And this angle is congruent to that angle. Now, obviously, it's not beautiful to look at, but when you think about a rhombus and you see those diagonals drawn, I want you to know that these four angles, they're all going to be congruent because we knew that the big angles, this angle and this angle, were congruent. So if it's bisecting them, those two little angles are also congruent. And these angles, all four of these, are also going to be congruent. So they might ask you things like this. If, or given that GDEF is a rhombus, find the measures of angles 1 through 6. So if this little angle here is 27, we know that angle 4 is also 27. And the ones on the opposite side, those two pieces of angle G, those are also going to have to be the same. So 1 and 2 are also going to be 27 degrees. Then they want to know, let's see, angle 3. Well, angle 3 is right here in the middle. Well, what did we just learn about the diagonals? Well, up here, it said the diagonals of a rhombus are perpendicular. So if DF is perpendicular to GE, then that's going to make that angle 3 a right angle. So angle 3 is going to be 90 degrees. I'm going to erase some of this that I've drawn on. Now for 5 and 6, we know that 5 is congruent to 6. But the question is, what are they going to be? So there's a couple of different ways we can look at that. But we know that since a rhombus is a parallelogram, we know that angle F and angle E have to be supplementary. So they have to add up to 180. Well, I know that angle E is made up of a 27 and a 27. So together, angle E must be 54 degrees. So if I do 180 minus 54, then I get 126. So angle F is 126. Well, that's all of angle F. That entire angle right there is 126 degrees. And since this diagonal bisects it, 5 and 6 are each half of that 126. So they're each going to be 63 degrees. These work kind of like a puzzle. You kind of have to start with what you know and then work your way around the shape to figure out what else you can find. Okay, what's special about a rectangle? So a rectangle is, or a parallelogram is a rectangle if and only if its diagonals are congruent. So when we draw the diagonals of a rectangle, those two diagonals have to be the very same length. So this one says, find the lengths of diagonals W, X, Y, Z. Well, anytime they start doing that, let's draw W, X, Y. Let's make sure that's a Y, Z. And they want to talk about diagonals W, Y. So W, Y would be this one, that's W, Y. And then they also give us X, Z, which is this one. Well, those are both the diagonals, and since we know that the diagonals are congruent, we know that WY has to be equal to XZ. And WY is 16x plus 2, and XZ is 36x minus 6. And then they asked us to find the lengths, so we're going to start out by solving for x. We subtract the 16x from both sides, get all your x's to one side, get your numbers to the other side, so we get 8 equals 20x, divide by 20, and those are both divisible by 4, so we get 2/5 is x. If you want to say x is equal to 4/10, you can do it that way also. It doesn't matter which way you want to do it. And then they want us to find the lengths. Well, we know the lengths are equal, so we can plug our x into either one of those. So let's say WY is equal to 16 times 4/10 plus 2. So that's going to be 6.4 plus 2. So WY equals 8.4. And they're both the same, so we're good right there. We've solved for both of them. All right, then we have the square. Well, the square has all of the properties of rhombuses and rectangles. So that means for a square, the diagonals are going to be perpendicular. The diagonals are going to bisect the angles. So you often come across pictures of squares where they've drawn the diagonals. It's good for you to know that when they do that, those two angles are going to be congruent. So they're both always going to be 45 degrees anytime you know that it's a square. We know the diagonals are perpendicular, they bisect the angles, and then because it's also a rectangle, the diagonals are also going to be congruent. Now, it's important to remember that the diagonal is not going to be the same length as the legs, because we can see that it's a right triangle. The hypotenuse has to be longer. Okay, we're going to see some questions that look like this. Decide whether JKLM is a rectangle, a rhombus, or a square. Give all the names that apply, and explain your reasoning. This was a big one on the homework we had trouble with last time. When they ask you to explain your reasoning, you want to be sure that you're giving complete sentences. You're not just writing down the mathematics. So let's start out by plotting all these points. So J is 3, 1. So there's point J. K is 3, -3. L is -2. Let's see, -2, -3 is L, and M is -2, +1. So we're going to draw our shape here. And the first thing I notice is that these two lines are both vertical and these two lines are both horizontal. So we know that the angles are right angles, which means it's definitely going to be at least a rectangle. Now, a rhombus and a square, all the sides need to be congruent. So since these are just vertical and horizontal lines, we can just count to find the length of them. We don't have to use the distance formula or the Pythagorean theorem. We can just count. Now, if they're slanted lines, if they're diagonal, we can't do this. So let's see, 1, 2, 3, 4. ML has a length of 4. MJ is 1, 2, 3, 4, 5. So we know automatically that it's not going to be a rhombus and it's not going to be a square. So now comes the time for us to explain our reasoning. There wasn't a lot of math to be done there as far as calculations. So most of the work's going to be here in our explanations. So I'm going to say something along the lines of, since MJ and LK are horizontal lines and ML and JK are vertical lines, the angles are all right angles. And then I would say since, okay. So let's see, instead of saying since again, that's kind of redundant, let's say JKLM is a rectangle. Oops, a rectangle since all 4 angles are right angles. We don't really need to explain why it's not a rhombus and it's not a square. We could if we wanted to. We could go ahead and say that JKLM is not a rhombus or a square because none of the sides are, or because all 4 sides are not congruent. And we could say it that way. But be sure that when they ask you to explain your reasoning, you actually make a full sentence statement. You may need to say, like, MJ and LK are, oh goodness, I did that. Yeah, that was right. MJ and LK, they're horizontal lines. But you might need to say they both have a slope of 2/3, or they both have a length of 5, or whatever you're saying. Be sure you include the mathematics in your explanation, and be sure that your explanation would make sense to someone else who hasn't been listening to the lesson. All right? Okay, let me know if you have any questions.